Hello everybody, and welcome back to the channel. This is Michael, KE4EST, and we are back here with the Eico Model 315 RF signal generator. So I'm going to start here at the front and kind of show you what I've done here. I have replaced, as you can see probably right away, these connectors with BNC connectors. Cleaned up the front, cleaned the knobs, all that. And this here, this bezel, I took it off, took it and stripped it down to paint it. And I guess for everything dried, I've got a couple little marks here and there I need to kind of maybe buff out or whatever. And you can see the cracks are still here from where it was broke. I tried to put some like auto body putty and stuff on it and sand it down. I never could get it where it looked like I wanted it, and it's still going to have a bow here in it and all that. So I just took that back off, stripped it, painted it, and as you can see, yeah, you can see that in the camera. It's like a dark gray color. It's supposed to be black. It's not black. So I don't know if I'm going to leave it like this or if I'm going to... I went ahead and decided to put it back on and have a look at it. I may go back and go with black. I mean, I looked at the can and it says gloss black, hammer tone. And I've used it before. I don't know why it's turned out like this, but... Anyway, it's a dark gray now. So, that's what that is for now. And... maybe you can hear that. You can tell it's thin to me. I put a new piece of glass in here, and what I did was, let's see, yeah, it's up here. I used one of these glass cutters that I've had around for, a couple years ago. The wife was getting some kind of crafts or something, and I got one and figured out how to use it and was doing some stuff with her. And I've not used it since then, so I'll try it before I go and spend money, at a glass shop or something, whatever. So what I did was took a piece of 8x10 picture frame and cut it down this way and cut it down this way. And then if you ever do one of these, you'll see you have to lob off these sides here. You can't just go with a piece of rectangular glass. It ain't going to work. It's got to be lobbed off the way they've designed it inside here. So I had to make, 4 cuts. Because it's like 9 3/4 this way, and about 5 5/8 or something this way, and then it still sticks up here. But the way they've got it designed inside of here, I should have took a picture of it. I don't know why I didn't. I had to cut these off so very carefully. So anyway, so that's the way I did it. I did it at home myself. So did that. And then let's take, let me get this thing all turned around here and reposition the camera, and I'll be back. Okay, I'm back. Maybe you can see everything here. So to start with, you see these capacitors here. It was this can. I left the can, and I'll show you the top side here in a minute, but left the can capacitor in and went with these. You can see the tabs are still there, but they're not connected to anything. Left that for aesthetics, but changed out and put these electrolytics here. I moved them over to here closer to the tubes. Let's see, changed out of course these capacitors. This here, you see that paper capacitor that was here, changed that to a safety capacitor. And then over in here, this capacitor and this capacitor hiding back here, and there's one hiding right down in here. You can see that right in there. Change that out. Of course, cleaned up all the contacts, and I had to really clean those tube sockets. They was really dirty, really crusty, like, corroded up in here in these tube sockets. I cleaned those too while I'm thinking of it. Went through and checked all the resistors, and there's one back in here. this one here, and there was another one. I think it's hiding back here. Yeah, those three were pretty far out tolerance, so I changed them out. And this one over here, it checked out pretty close, and this one back here checked out really close. I don't know. Let's see if we can zoom in on that to show you that usually I don't leave those. Yeah, you can see that's a roundy. One, or so was it? Maybe that's 1 watt. Looks like a 1 watt. Maybe they're calling it 2 watt. Let's see what they're calling that. Yeah, 1 watt. 1K resistor, and it's a roundy. And it checked out. Supposed to be 1K, it was like 1.01K. You know, so I decided just to leave that. And straightened up this coil in here. It was, if you remember in the first video, or go back and look at it, it was all stretched out, weird looking. Of course, you know, somebody's probably put this together at home or whatever, but fixed that. And let's see, move the camera a little bit there. And I changed this, or didn't change the coil out, but I fixed this coil. It was all been out of shape kind of there. I straightened that up some, and I don't think it was bent out to, you know, for a frequency reason. I think it was just, you know, somebody tried to wipe the best they could. I kind of just left it, but straightened it up and resoldered everything in there. And right here, resoldered this to the chassis, and this here potentiometer on this end, this dual gang potentiometer was supposed to have a ground from here to here, and to, you know, to ground, and it did not have it. It was complete. I mean, it was just nothing there. So I think there was a jumper between the two of them. That was it, which is kind of odd. Maybe the guy missed that or something. I don't know. But anyway, done that. I think I replaced one resistor in this box here. I've already put the cover back on it there. And the attenuator network. And so that's what I've done with it. This line cord looks okay. Maybe it's a little weird the way that is, but that's the way they've got it right next to this tube socket. So everything looks okay in here, other than that. So I need to get this cover back on this to do the alignment on it. But let's show you a couple things up here. Of course, if you remember, this tube here was bad. This was a 6SL7. So I replaced that. These two tubes were fine. This is what, OD3. I know it's a VR150 also, they call it, or yeah. I think I'm actually be on the, you can see it in the camera, but I'm moving my head where I can get, yeah, OD3, 150 volt regulator. Sometimes I get in my head which one's right, the OD2, OD3, which one's which there, but yeah, that's the 150. This here, this 6X5 tested out good. Of course, I left that can there just for looks, but it's not hooked up anymore. This was bad. The oscillator tube, you know, for the output, for the audio, is this 6SL7. And the main oscillator tube, the 6C4 back here, was completely dead. I mean, it wouldn't even light up. You know, and I got to testing it and everything. Just, I first got everything changed out. Got a new tube stuck in there, you know, and I didn't, at that point I hadn't tested the tubes except for this one. I knew it just, you know, it was bad, so I changed it. I pulled everything, cleaned the sockets, put it back in. Wouldn't oscillate at all. So of course first I'm thinking, no, and I was back in this section here, I had to move some wires, and somebody had to take some wires off to properly get in there without, you know, burning wires with the soldering iron to get, you know, basically change out this BNC jack and stuff. And I thought, oh, I forgot a wire. I stuck it in the wrong place. So I went back and looked at that, looked at the pictures. Always when you're doing this stuff, like I've said, take pictures, take plenty of pictures. And I was like, well, no, everything looks right. I was like, okay, so why won't this thing oscillate? And then I was like, oh, duh. If the tube isn't working, it's not going to oscillate. So let's try that. You know, I got so worried about that in there, thinking I'd, messed up something. So, so let's just check the tubes. So these two checked out fine. This one, I said, well, I'm going to go ahead and test it, even though it was supposed to be new in a box, or, new old stock, but it tested really good. So pulled the 6C4 out, and I'm waiting for the tube tester to warm up. It's like, and then like, never did. So I thought, well, that's interesting. So we put a meter on it, and I was looking in there real good and whatever, and I didn't see nothing ever glowing. The cathode never was lighting up. So I was like, cathode tube's not lighting up orange. So I put a meter on it, and it's open. The filament was open. So I don't know what caused that, but anyway, so I got plenty of these 6C4s. This one here is a little harder to find, but 6C4, I got another one stuck in there. It came to life. So, and then the other thing I'll show you real quick. Here's your variable capacitors to set it up when you go through the alignment. And this is band A, B, C, D, E, and F is this one right in here, which I think is supposed to be brought out more. Like, see how it's kind of at an angle? Maybe you can see that. It's more of an angle, but I think it's supposed to be more downward. I'd have to look. And by the way, thanks to one of my viewers and subscribers, that's one of the ones that's in there with most of the videos. He watches about every video I put out. Let's see what, if he had a name, it might be easier to remember. What does he go by? Give me just a second here and I'll pull it up on the computer. He's the master. If you go back and look in part 1 of this video, and down in the comments, he left a link, because I'd found plenty of schematics. Well, actually, the first schematic I found for this was really blurry. Somebody, did a bad job of scanning it in. And then I did some more hunting around. I found a instruction manual, and I found a lot better schematic. Because some of the schematics is so blurry you can't even hardly read the, I can tell, though, that's probably a C, and of course it's right next to a capacitor. Is that C5, C10? What is that? It's so bad. But then I found a real clean schematic. But I was looking for a construction manual to see, how everything's supposed to be wired. Of course, you can follow it through the schematic and look at it. But anyway, he left a link to things, so thanks for that. He's the master. But anyway, so let me get this cover on this, and we'll hook this up and look at it on scope, and we'll go through a little bit of an alignment and see how it looks. Okay, I'm back here. Maybe you can see that oscilloscope in the background. Let me just move the camera. Let's just put it right on that for a minute. I am on the band B, which goes from a little below 200 kilocycles up to about 600 kilocycles. And you see me moving the dial here. Right here is, let's go down to 200, because that's where I'm going to start anyway. Okay, that's pointed at 200. According to the scope, it says 198.07. That's what it looks like. You can see there. These things are designed to be rich in harmonics. It ain't going to be a perfect, pretty sine wave. Just like the Heathkit generator behind this one. So it's going to be kind of like that. But it'll still work, to do your RF alignments on things and whatever. If you want something fancier than this, you're going to have to spend a lot more money. And, this was what it was, back in the time this came out, and it was a kit. But there it is. That knob on the front looks like it's working good. The attenuator. Go to different bands, you can see. They get a little bit different. There's a band A. There's band B I'm going to start with. So let me go down first of all. Here. So, like I said, you can find plenty of these on the internet. But here's the schematic for it. It's pretty straightforward and basic schematic. There's your 6X5 rectifying full wave rectifier. There's that big white resistor that was in there, the 6K resistor. There's those two capacitors, 10 microfarad that I put off to the side. Now they're not in the can anymore. There's your 150 volt regulator coming up and feeding your voltage up. There's your attenuator network. This here's your 6SL7. I do believe it has to be. That is feeding, and all this really does is your modulated 400 hertz tone. And then here's your network over here from your band switch to go through your different bands. And these adjustment capacitors here, trimmers are what's right there. You can barely see at the edge. And the coils that go with them, and that's all coming, here. Here's the tuning capacitor when you turn the knob on the front, and there's your 6C5 for your oscillator. Here's your feedback coming in, so you're making your oscillator, and then it's going out to the other half of the 6SL7 for your output. One half of it they're using for, let me study this a minute. Yeah, that's got to be it. Yeah, the 6L7 is a twin triode. So anyway, there's your oscillator from there, and here's your output. I mean, it's pretty straightforward schematic. So what I'm going to try to do is I'm going to try to get the camera where you can kind of see. You're not going to be able to see the face. I should have set up two cameras. But anyway, let's see if we can see the... Let's move this down to here. I wish. Only thing about this stuff out of my way here. Only thing about this... signal generator I don't like is it don't have a standby switch. It's either on or off. And you can't flip it to standby and leave everything running and warmed up, ready to go, and just kick it in if you want to. But that's the way they designed it. So maybe I can do this where you can still see the frequency counter back here, and you can see these, and I'm on band B, and I've got the dial set at 200 kilohertz. And so let's see here. So this is A, B, C, D, E. Now these nuts, like I was mentioning before, you gotta make sure you back out, these nuts. Back them off, do your alignment, and then tighten them back up. Don't go crazy tighten them, use common sense, but tighten them, a little bit of a tightening there to hold them in place. And I've went through and loosened these up already, so let's go here, starting with B, because I'm not going to go through every band with you. I mean, it's the same all the way through. But I've got the dial right now on the face, everything's set right at, if I'm looking straight at it, 200 kilohertz. So if I bring this, you can see it's coming up. I'll probably have to find a happy medium. If you find this is way off, you can go in and mess with the coils a little bit. You can adjust the capacitance, you can add a little capacitance in line. Small picofarad with these variable capacitors. You can add a little bit of, take you a little, maybe start with a 100 microhenry coil or something. inductor and stick it in line with the coils. You know, you can go and modify it and get it closer, but I'm gonna bring this up. Well, that's as close as it wants to let me get it, huh? Okay. I keep going, it starts to go back the other way. So there's 199.6. Now let's bring this across and let's go the other end. Going to the other end, if you it would be nice if they'd put, you know, variable coils in there too. We'll see. Let's just go to 500. Now that looks like 500 to me. We're at 537. So I can bring this back. Oop. That's moving quite a ways, and it probably is not going to be as much movement. See how much on this end I'm getting a lot of movement. See, I went, you know, right there's, I probably passed it. Nope. Right there I went, you know, like 30 some kilocycles. Whereas before, when I barely, you know, moved that a little bit, it didn't go very far. So let's go to the other end and look at it. See, we're at 198 at 200. You know, I could probably, well, let me see. Oh, this thing. The knob on the front, you turn it, you know, to the left for the needle to go to the right, and vice versa. So it's confusing a little bit. But so there's about, let me look at this thing. There's about 200. So see if I bring this up now to, I'm just, you know, look how much little movement we're getting, about the same turn. That's close to 200. Let's just stop there. And let's go back to 500. So we're back in 532. So what I'm going to do is go all the way to 600. 664. Look at that. Let's bring this back. Get that closer to 600. And I might not be right on it. That looks closer to right on it. That's even closer on the dial. Now let's go all the way back across to 200. Now at 198 again there. So let's bring this up a little bit. Oops, let's not go too far. And we'll bring this across. Put this about on 600. 613, huh? So bring that down a little bit. Peg that thing out. Alright, let's bring it back. So you have to sit and play with this back and forth to get, you know, find that happy medium. And then what you want to do is go in and start, you know, if you want to use this as your primary thing and that's it, you're not just going to restore this just to be restoring it. You can go in and add some capacitance. You can go and add some inductance. You could go in and start removing turns off the coil, but it's being glued and stuff, so that can get interesting. Be careful doing that. You can really mess it up completely. Your best bet would be to add a buffer circuit in this thing and have an output on the back that would feed, you know, a signal generator. So like right now I've got the output going into that, but if I had an output coming off that T over there going to something else, this is going to skew it a little bit. If you had a buffer circuit coming off of this, that way no matter where the attenuator was set, no matter what you was doing on the front, you know, it wouldn't really affect the frequency. So let's try C. And C says 550 to about 1700. So let's go and put it on 550. Which is about right there. 542. So that's the next one up here because we're on C. Okay. I bet I won't get that on 550. Well, I might. Okay. So there's close enough for what I want to do right now. So let's bring this up. I'm not worried about the other numbers out there. I just want to. And the other end is 1700 or 1.7 megahertz. Wow, 2. So if I bring this back, see, just barely turn it. It's making a big swing on this thing. Let's get it back closer to 1.7. 1.8. Let's stop at 1.8. Let's go back to 550 real quick. 545. Get this closer to 550. You know, these things ain't gonna be perfect. And go back to 1.6. Not bad. So like I said, we could sit and play with it all day and go back and forth and get it as close as you can. Then, you know, you want it better, you can. Okay, so let's try. Yeah, let's see. I don't want to mess with F. It's in there. Let's just try D. D is 1.6 to 5.0. Okay, so see how close you are. 1.6 to 5.0. Well, let's go to 3. Wow, really? Alright. If I get on the right band. Okay, there's 3. Wow, that ain't bad for not touching this thing. It works out that way, don't it, sometimes? There's 3. Well, let's see how good you are. Let's go to 2. That ain't too bad. Let's go to 4. Well, that ain't bad either. Oh, D. I don't even touch D. But anyway, so there it is. The Eico. Disconnect that. So there it is. The Eico. Get that light out of the way. 315. Restored and ready to be used again. Well, it needs off camera. Go back and touch up some more of the. You know, go through all the bands real good, A through F, and check everything out. I may have to take this back cover back off and mess with the F and all that, but there you go. I didn't. Man, this video's already getting long enough. I did test out the audio, and it's 387. It's supposed to be 400 hertz. It's 387, so that's close enough. You know, if it's way off from that, you want to go in and check the circuit or modify it or whatever. That's something else, you know, you can do. You can change out capacitor, resistor. A lot of times you can just change the resistor in the circuit and if it's a little bit too high, a little bit too low. But there it is, the Eico Model 315. So I hope you've enjoyed this video and helped somebody out. And until the next video, this is Michael, KE4EST 73.